In section 5.3, we're taking these rules for the exponents and just looking at general polynomials. So we're multiplying polynomials. Before I get to actually multiplying polynomials, I do want to talk about the distributive property. This is the distributing multiplication over addition. It doesn't really matter how many terms we have on the inside of the parentheses. We can distribute, if we have a times a bunch of things on the inside of the parentheses, each of those individual terms would be multiplied by a. So you can see I would distribute it out a bunch. We'd have a times b, ac, ad, and so on. So in this instance, if I have the 2x squared multiplied by the contents of these parentheses, I would take 2x squared times x squared. Well, 2x squared times x squared plus 2x squared times 3x plus 2x squared times 5. Now, I don't generally like writing it out like this. I generally like simplifying it in the same step. I'm just doing it this one time, so you can kind of see what's happening. I'm taking the 2x squared times each of these three terms, and these are the things I'm going to be simplifying. So we have the same base, and we're multiplying these things together, so I'm going to add the exponents. This is 2x to the fourth. 2 plus 2 is 4. 3 times 2 is 6, and 2 plus 1 is 3. So you have to be careful. I'm multiplying my coefficients because it's multiplying. When I'm multiplying my x squared times x, this is 3 copies of this x. That's why I do the adding the exponents. So you just have to be careful when you're doing this to make sure you're doing the correct operations, multiplying versus adding. It can be pretty tricky when you're first getting at it to make sure you are using the proper operation. Alright, so on this one, how I like to do these is I just do the coefficients first. So negative 2 times 3, this is again using the distributive property. So taking the negative 2 times 3 is negative 6. X times x squared is x cubed. And there's no y to combine it with. So that's my first. When I multiply this outside by the 3x squared, this is what I get. Next, I'll look at this middle term. Negative 2 times 5 is negative 10. X times x is x squared, and y times y is y squared. Distributing to the third term, negative 2 times 2 is negative 4. X times, well, there's nothing for it to combine with. And then y times y squared is y cubed. I should take a moment to point out the fact that these are in standard form. The insides of the parentheses were actually in standard form in this first example. So when I multiply by 2x squared, as long as I don't change the order, the result is still going to be in standard form. This was a degree 2, degree 1, degree 0. When I multiply by this degree 2 thing, you'll notice we increase to degree 4, degree 3, degree 2. So they still stay in the same order. The same thing goes here. I'm multiplying by a degree 2. It started out 2, 2, 2, but they're in alphabetical order, x, 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 y, and y, y. When I multiply by this thing, it doesn't change the order at all, because kind of this is x, 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 y, this is x, x, y, y, this is x, y, y, y. If I was to write those words out in a dictionary, that's the order they would occur. All right, on this one, there's fractions, and there's also the thing I'm distributing is on the right as opposed to being on the left. That doesn't really change anything, though. I'm still going to be doing this 1/2 z cubed. I'm distributing to each of the 3 terms on the inside of the parentheses here. So 1/2 times 4/3, that's, I could write it as 4 over 6, but I'm going to just go ahead and reduce that and count it as 2/3. Z cubed times z squared, 2 plus 3 is 5. It's supposed to be 2/3, not 2/2. This is z to the 5th. Again, 2 plus 3 is 5. So that's the first term. Distributing to the second term, 1/2 times 8 is 4. Z cubed times z, well, 3 plus 1 is 4. This is z to the 4th. And lastly, 1/2 times 1/4. There's not really any canceling I can do there. This is just going to give me 1/8. And there's no z's to combine this with. I get z cubed. Be careful when you're writing these not to put this z. A lot of people have a tendency to accidentally make this z, or whatever your variable is, make it look like it occurs down in the bottom part of your fraction. That is definitely not correct. If you said 2/3 z to the 5th, this would be something that's very different. However, if you wanted to put it up in the top part of the fraction, this is actually equal to this 2/3 z to the 5th is the same thing as 2z 5th over 3. Those are equal to each other, but when we're talking about polynomials, we like to have the coefficient separate from our variables. So this is definitely the preferable way to write it, although this way is correct for that first term. Of course, there'd be other things going on there as well.